This is Intreys, an evidence correlation workbench for network and security investigations. In this demo, we'll work a real case, a packet capture from a small museum network where something has gone badly wrong. I'm signed in as an analyst, and I'm starting with a completely empty workspace. Everything in Intreys starts with evidence. The dashboard accepts packet captures, email files, cloud audit logs, network flow records, and operating system logs, all into one investigation. I'll load the museum's capture file. Parsing, protocol dissection, and the detection pipeline all run locally, and on a capture this size, results come back in seconds. The dashboard gives me the shape of the problem immediately. 1,700 packets across 30 minutes, 6 hosts, 355 sessions, and 12 alerts. The overall risk score is 90, critical. And the top risk panel already points at one internal host, 10.128.0.231, flagged for port scanning with 6 separate alerts against it. That's our pivot point. The alerts view explains each detection in plain language, with the MITRE AD and CK technique attached. Our internal host probed 35 ports across 5 other machines. That's network service discovery, classic reconnaissance. The same host then sent over 100 SYN packets at an external server, a denial of service pattern. And here's the root cause, Telnet. 2 different external addresses logged into this device over an unencrypted protocol, and Intreys captured cleartext credentials on the wire. An internal device scanning, flooding, and taking remote logins from strangers. This is starting to look like a compromised IoT device. Instead of reading 12 alerts one by one, I can ask Intreys for the attack narrative. It correlates alerts, haunts, and indicators into kill chain order, 2 attack chains, 12 events, reconnaissance, execution, and command and control, with 1 critical event that needs immediate attention. 5 MITRE techniques observed, from network sniffing to denial of service. This is the story of the incident, reconstructed automatically. Now let's confirm the root cause. The forensic scan digs through every packet and stream, extracting strings, indicators, and credentials. And there it is. A Telnet login to the device, as root, with the password XC3511. If you've worked IoT incidents, you know that string. It's a factory default password famously abused by Mirai family botnets. The extracted indicators below show busy box paths and embedded Linux file system activity from inside the session, exactly what bot malware does right after it lands. The artifact gallery collects every file Intreys reconstructed from the traffic. Telnet session artifacts, HTTP transfers, and one that matters most, an ELF executable, a Linux binary, delivered to our device over plain HTTP, flagged critical. That's the payload. Every artifact has evidence details and hash lookups 1 click away. The network map shows the blast radius. Our museum device in the center, talking to 2 addresses in Amsterdam, 1 in Russia, Google DNS, and the flood victim. The high-risk path is drawn in red. From here I can pivot into any node and open a full investigation panel on that host. Geolocation puts the infrastructure on the map. 5 external addresses resolved. The 2 Amsterdam hosts are flagged as proxy infrastructure. 1 address traces to Russia, and the flood target is a US business connection. Attackers hiding behind proxies, controlling a device on our floor. That's the picture. Correlation workbench is where everything lives on one timeline. 366 events from this capture, clustered and pivotable by IP, domain, user, and hash. In a bigger case I'd drop email files, cloud audit logs, and host logs in right alongside the packets, and Intreys would correlate them into the same investigation. 1 investigation, every evidence family, 1 timeline. Finally, the findings need to leave the tool. The report builder generates a full investigation report, with executive summary, key findings, indicator tables, and MITRE mapping. Raw data exports as JSON or CSV on every tier, and professional licenses add PDF and Word reports. Sigma rules, sticks bundles, MISP events, and SIM integration. Verdict for this case: an internet-exposed IoT device with a default telnet password, compromised by botnet malware, used for scanning, and a denial-of-service attack. Containment: isolate the device, rotate credentials, block the listed infrastructure. That's a complete investigation, from raw packets to a defensible conclusion, in a handful of minutes. Intreys. Look deeper. Find everything.